In lesson 12.3, we're going to talk about the law of sines. And I kind of want to skip this slide. This slide talks about finding the area of a triangle and finding the height and why two different parts of the law of sines that we're going to be talking about can be developed. And you can pause this and take a look at it and read it if you want to, but I kind of want to get into the meat and potatoes of the law of sines. And then I like to teach through context, so I'll show you what's going on in the context of a couple of problems. First of all, I want to tell you that the area of any triangle can be found with the formula that's down below here. So this formula, A equals 1/2 AB sine of C, is talking about whenever I'm given any triangle, and I'd like to show you an example. Let me see if the next slide has one of those. If not, I'm going to do it on this one. Does not, so let me just talk about it on this one. So let's say, just as an example, off to the side here, I see the following triangle. Let's say that I see a triangle that looks like this. I know that this side is 10, I know that this side is 20, and I know that this angle is 30 degrees. The way that I would find the area then, based on the formula that I see down below, is I know that my area would be equal to 1/2 times the first side, 10, times the second side, 20, times the sine of the angle that is in between the two sides I just talked about. And I can type this directly into my calculator. And if I type in 1/2 times 10 times 20 times the sine of 30, my answer that I get would be 50. So this would be the area of the triangle, 50. And I don't know what the units would be right now, but whatever they gave you would be in some kind of units squared. And basically you take 1/2 times the two sides times the sine of the sandwich angle in between. And that will give you the area of any triangle. So this is one of the benefits of knowing why the law of sines came about. This is not the law of sines. This is just an area formula that you can use on any triangle. Area formula. On this next slide, though, is the law of sines. And this law of sines is really pretty simple to understand once you kind of see its pattern. Because remember, math is the study of patterns. And so what I notice is, if I look at the sine of any angle called A, and divide it by the side that's opposite to it, little a, that should be the same relationship as looking at the sine of the angle B in the triangle divided by the side that's across from it. Or I could do a third comparison. I could look at the sine of angle C divided by the side that's across from it. And it doesn't matter which of the two you choose. So for example, I could choose the green versus the blue. I could choose the green versus the pink. I could choose the blue versus the pink. What they're saying is that the relationships between the sines of an angle and the side opposite are the same no matter where you are in the triangle. Let me show you how this works. In one example, I would like to find an angle, and in another example, I'd like to find a side, just to show you what's going on. So first example. In this first example, what I notice is that I'm given an angle 59 degrees. And I notice that there's a side across from it, 350. So I can say that the sine of that 59 degree angle divided by 350 should be the same exact relationship as the sine of the 38 degree angle divided by the side that's across from it called little b. So what we've done here is we've set up a proportion, that's where we have two ratios, or in other words fractions, that are equal to each other. And this is the relationship that I was talking about. The sine of any angle divided by the side opposite should be the same no matter where you are in the triangle. At this point, when you have two fractions, or in other words ratios, set equal to each other, you do the cross multiply thing. So that means we're going to multiply the sine of 59 times b, and 350 times the sine of 38, and we're going to go from there. So from the yellow highlight, if I write down what's going on, I would have b times the sine of 59 degrees. Then that should be, from the green highlight, 350 times the sine of 38 degrees. Now, if I look at the right-hand side, and I just type that information into my calculator, that is, I type in 350 sine of 38 degrees, I end up with 215.48. On the other side, I don't have anything besides the sine of 59, so I'm just going to type that in, sine of 59, and I get 0.8572. And don't forget that's being multiplied by the b. Now to find out what your b is, of course, you would have to divide both sides by the number that's with the b. So I divide both sides by the 0.8572 to find my answer. And when I divide the 215.48 by the 0.8572, I end up with the fact that my b is 251.38, and that would be in centimeters, of course. So in this particular example, we found a side using the law of sines. In the next example, I'm going to show you how to do an angle. So here we see another example of a triangle, and I notice that in this triangle, I see that I have angle A at 69 degrees, and the side across from it is 250. So I'm going to start out by saying, hey, look, I know that the relationship, the sine of 69 degrees divided by 250 should be the exact same relationship as the sine of angle B, which I don't know yet, divided by the side that's across from it, which is 150. And again, what we're going to do to solve this is we're going to multiply diagonally. So we have the green multiplication and the yellow multiplication. And so I start out by writing down, let's say, the green multiplication. So I have 150 times the sine of 69 should be equal to 250 times the sine of angle B, which I don't know yet. On the left-hand side, when I multiply 150 times the sine of 69, I get 140.037. And the 250, since I don't know what the sine of B is, I just have to leave. But now, in order to find out what the sine of B is, I'm going to divide both sides by 250. And the reason, again, that I'm dividing by 250 is because it's being multiplied by the sine, so I want to cancel out the 250s. And when I get done dividing by 250, on the right side, all I have left is that sine of B, of course. And on the left side, when I divide the 140.037 by 250, I end up with 0.5601. So that if I want to find the B, which is an angle, I know that angle B has to be second sine, because we're working with sines now, of 0.5601. So I do second sine of that number, and I get that my angle B will be 34 0.07 degrees. And the only difference between this problem and the previous one is that in this example, we get an angle as an answer, and in the previous one, it was a side. So as you do this, you set up the ratios. The sine of an angle divided by the side opposite equals any sine of an angle divided by its opposite side. If you were looking for the highlighted parts, this was the 150 sine 169, and this is the 250 sine of b highlighted. On the previous page, when I was doing that, the sine of 59 times b was this yellow highlight, and 350 sine 38 was this highlight. And here, in general, is the law of sines.